Hello guys, today we're going to talk about circle graphs and how they're applying to percent. So circle graph is a graph that displays parts of whole amount. So we do know we have a variety of graphs, but this particular one, whole amount, but this particular one does have to do with percent. So circle graph percent represent parts out of 100%. Okay, so the sections that we're seeing, they all have to be adding up to 100%. That is important to keep in mind because, again, that information will not be provided to you guys. So just always keep that in mind. The data represented in the circle graph can be used to solve problems, including part-to-part comparison. So we're going to talk about different values on our circle graph and compare one section to another, and part to whole. So part section of the graph to the whole quantity. So part-to-part comparison or part-to-whole comparison. So let's take a look at the first example. We have the circle graph shows the percent of type of flowers planted in flower garden. If there are a total of 150 flowers, how many more of them are impatiens than begonias? All right, so keep it in mind, guys. Graph represents 100%. Not 100 in quantity of whatever you guys are analyzing. So in our situation, it's 150 flowers, okay? So first step, determine the amount of flowers that are impatiens and begonias by converting the percent to fraction form or decimal form. Okay, so when they say in fraction or decimal, this is an option for you guys to use percent equations or percent proportions to determine your quantity. So for example, in impatiens, we have 36% of 100. So 150. Woo, almost made that mistake, guys. So I'm going to stick with equation format, okay? So 36% would be 36 hundredths, and I'm multiplying by 150 because that's the total of my flowers. That gives me 54 flowers. And I'm also kind of doing a little bit of a judgment. 36%, it's about 1/3. 54 is about 1/3 of 150. So yes, it is definitely a reasonable answer. And so I am comparing impatiens. So 36 was impatiens. And I need to compare them to begonias, which is 14%. So I'm going to do the same thing with begonias, and I will have 21 begonias. Okay, and then of course the basic comparison to this is the difference. And so 54 minus 21, that gives me 33. Okay, so the difference comparison. Again, guys, on these operations right here, we could have set up a percent proportions if that is the method that you guys prefer. All right, let's take a look at another situation. Write a ratio that compares part of flowers that are geraniums to the part of flowers that are petunias. Okay, so again, we're still referring to the same graph. And so now the difference of this question, guys. In the first scenario, we needed to find the quantity of the flowers and just kind of find the difference between them. And in order to find the quantity, we had to find the part of 150. In our second step, yes, before we compare the flowers, we need to find the quantity as well. So we have two flowers. Geraniums were or are 10%. Well, that's fairly easy. We've done this mental math already, 10% of the value. And then for petunias, we have 28%. 28%. That's going to give us, so again, several methods, whichever one you guys would prefer, that will give us 42 flowers. So this is what we're going to be really doing differently today. It says, determine the amount of geraniums and petunias in right part-to-part ratio. So in first scenario, we just find the difference between them. In the second scenario, we're going to write them out as a ratio. So ratio would be, this is our geraniums to petunias. That's what they, excuse me, that's what they refer to, 15 to 42. This is the ratio that we will have. The decimal format would be 357. Again, I did a little bit of rounding here. It does not divide super nicely. And so when I'm converting this, again, 35 and 7/10%. If they're rounding, requesting certain amount of rounding, just follow through with their directions. Again, super important, guys. Keep in mind, sometimes your percent could be in a not whole form, so 35 and 7/10. And the very last step, guys, they're asking us to interpret what in the world does it mean? Ratios meaning incomplete sentence. So when we say we have the ratio of 15 over 42, and we try to interpret, I would say, if I were to reduce this ratio, I will have the value of about 1/3. So during my comparison, I can say that number of petunias, let's compare geraniums, since I do have a 1/3. Geraniums is about 1/3 of number of petunias. You don't see it, here you go. So again, just let's go back to our chart in the initial circle graph, guys. So when we look at the geraniums right here, what do we see? Yes, it's 10%. Petunias, 28%, which we can round up till about 30. Is 10 about 1/3 of 30? Yes, it is. Okay, we did find the actual quantities, and the quantities are also true to that approximate relationship. All right, and on the flip side of your note, guys, we're going to take a look at the comparison of the two circle graphs. I'm actually going to use a different note so it's not bleeding through. So the concept is going to be absolutely the same, guys. When you are comparing two charts, you are paying attention to the value of each of the chart in actual numbers. We know that they're always going to be adding up to 100%. But what's happening here, for each circle graph will represent different quantity of those items. So in our situation, we have 7th graders and 8th graders, and they were questioned about or interviewed about variety of activities, and you can see the breakdown of that survey. Let's take a look at our example and analysis that we're going to be doing. So example 1, Charlie claims that more 7th graders than 8th graders prefer choir. Is his claim supported? So we have 32 for 7th graders and 15 for 8th graders. So yes, guys, numerical percent value is greater. However, guys, we do not know the quantity of 7th graders or quantity of the 8th graders. So this is going to be really, really important because we have to say no, his claim is not supported. In other words, guys, this is he correct? Well, we can say, I actually don't know. Is there enough evidence, enough information? Like, I don't know. I don't see that, okay? So the claim is not supported because we have only percentages are given, not a number of students. So another way to rephrase the statement, and I really like that you guys have seen, it's a greater percent of 7th graders than 8th graders that prefer choir. That's how comparison could happen if you do not know the quantity. Okay, so if we do have the quantity, we definitely can analyze. So let's take a look at a couple of our exercises that follow this activity, these two charts. So we have Bella thinks that fewer 8th graders than 7th graders prefer sports. So again, guys, we're looking at the percent value. And so when we're saying, is Bella correct? Well, it's like, I don't know. I would say no, because I really do not have enough information, because we have to say it's fewer percent of 8th graders. That's going to be our statement. Super important. We only can compare percent without knowing the value. Javier claims that the theater is the least preferred by students in both grades. Is his claim supported? All right, guys. Well, this is very different because we have this statement that says that theater is least favored activity by both set of students. But when we look at 7th grade chart and the 8th grade chart, we see that the theater section has the smallest percent. So without even knowing the numbers, we can say, yes, his claim is supported. Both graphs have theater as smallest section. Okay, again, just as a part of the comparison. All right, number 3, Clay knows that there are 157 graders and 200 8th graders. How can he check Bella's claim? Is he correct? Or is it correct? So now we're actually going to come back and going to be able to check Bella's claims. So in order to check her claim, we're actually going to determine. So we have 157 graders, and 42% of them selected sport. That will make 63 kids. 8th graders, 200 of them, and we have 39 of them that selected sport. That would be 78. So yes, her claim is not correct. So even though 8th graders did have a smaller percent, we know that the numbers are going to be showing us the greater quantity of kids, because there's greater quantity of the total group of 8th graders. Question 4. If there are 157 graders and 200 8th graders, in which grade do more students prefer choir? All right, let's take a look at the choir statement and the numbers. So we have, again, same kind of process, 157 graders times 32%. That's going to give us 48. I don't know why I said 42. 48 students. And then for 8th graders, we have 200, and we have only 15% there. That will give us 30 students. So definitely this is 7th graders. Graders prefer choir more than 8th graders. All right, guys, we're going to be using this type of graphs tomorrow as we continue working with percent and budgets.